Hi, this is Terry. Welcome to my new podcast called ZorgStudio. I think it's pretty good. I use it all the time myself. The voice recognition works with any English speaker. You probably won't appreciate how useful it is until you try it, unless you have already had a bad case of RSI or trigger finger. The URL to the freely downloadable fossil repository is in the comments section. Anyway, I hope you enjoy the video.
So I want you to picture this sprawling, just completely neon-drenched office.
Okay, setting the scene. I like it.
Right. And there's a guy sitting there surrounded by literally the most expensive, sophisticated technology in the entire universe.
We're talking lasers, supercomputers, all of it.
Exactly. Automated security, weaponized gadgets, you name it. He is completely alone in this fortress of tech. And he starts choking on a cherry.
Oh, man. It is such an incredibly visceral image.
It really is.
Yeah, we're talking about Gary Oldman's character here, right? Jean-Baptiste Emmanuel Zorg from the movie The Fifth Element.
That's the one.
Zorg built his whole empire on these bleeding-edge gadgets, but in this moment of just, absolute life or death crisis, as he's literally suffocating.
Those machines do nothing.
Exactly. They just hum along in the background. They have zero situational awareness. It takes another actual human being physically walking into the room and just, smacking him on the back to save his life.
Okay, let's unpack this, because that cinematic scene, it isn't just random movie trivia today.
No, not at all.
It's actually the namesake and the core driving philosophy behind this fascinating project we're looking at. It's by a developer named Terry Porter.
Right, who goes by the handle Zorg online.
Yeah. And originally he named this project ZorgStudio, which was like a nod to that classic text adventure game Zork.
Oh, I remember Zork.
Right. But then he shortened it to just ZorgStudio. And the entire architecture of his software is built around that exact choking scene from the movie.
Which is such a wild inspiration for a coding environment. But the core philosophy Terry is pushing here is that, well, you can build the most powerful automated systems imaginable, right? Leveraging the absolute bleeding edge of artificial intelligence.
But the human has to be the point.
Exactly. The human is the point. Technology should not and really cannot replace human agency. It needs human context to even function properly. I mean, the machine doesn't know you were choking.
Only you know you're choking.
Right. Therefore, you have to be in the loop. Always.
Which perfectly defines our mission for this deep dive. Today, we are unpacking ZorgStudio. And get this, it is remarkably just a 59-line bash script.
59 lines. That is nothing.
Just 59 lines. Yet this tiny script orchestrates an entirely self-contained, offline-first development environment. It puts you, the listener, squarely in the driver's seat of this massive, multi-tiered AI engine.
It really forces a total reevaluation of what a modern software workspace is supposed to look like because, I mean, if the human is the critical component, the one actually providing the context, then the interface can't just be this chaotic jumble of, a dozen browser tabs and random terminal windows and scattered API keys.
Yeah, that's a nightmare.
It requires immense intentionality.
And I want to look at how that intentionality actually translates to the interface itself. Because when you execute that 59-line script, just typing ZorgStudio, you can pass it a project directory as an argument.
Yep.
And I assume it's doing some heavy lifting under the hood to set up a specific layout, because the sources mention it drops you instantly into a terminal multiplexer, TEE-MUX.
Right, explicitly spelling it out, TEE-MUX, so we don't accidentally pronounce it TMUX or something. But yes, it launches a highly curated 3-pane layout right inside there.
Okay, break down the 3 panes for us.
Sure. So on the left side, taking up exactly 50% of your terminal width, you have OpenCode. That's the AI coding assistant.
Got it. Half the screen is AI.
Exactly. Then on the top right pane, it's running Midnight Commander, which is, that classic visual file manager.
Oh, yeah, the retro blue screen one.
That's the one. And sitting right below that in the bottom right pane is just a standard shell prompt. And that is anchored directly to your project's root directory.
It's essentially, it's like a digital version of a professional chef's mise en place.
Oh, that's a good way to put it.
Right. Like when a chef sets up their station, the knife, the cutting board, the prepped ingredients, they are all bolted into very specific spatial locations.
You build muscle memory.
Exactly. In this layout, you don't have to leave the terminal to chop an onion, so to speak. You aren't constantly context switching, going from a browser-based AI chat, then over to a separate code editor, then digging around for a hidden terminal.
Because context switching is just the enemy of deep work.
It really is.
Every single time you minimize a window to copy a code snippet from a web browser, and then you have to paste it back into your local environment, you bleed focus. ZorgStudio anchors everything into a single keyboard-driven view.
Okay, but I will push back a bit on the novelty of the visual setup itself, though.
Fair enough.
Because terminal multiplexers have been around since, the 1990s. Splitting a screen into 3 panes is standard practice for basically most system
Oh,
administrators.
absolutely.
So the actual layout is just the chassis? What actually makes this an AI-assisted studio rather than just a tidy window arrangement? It has to be the engine running inside that left pane, right? The OpenCode assistant.
You nailed it. The chassis is merely the delivery mechanism. The engine powering OpenCode is where things get wild. It's a highly sophisticated 4-tier AI stack.
4 tiers.
Yeah, it does not rely on just a single monolithic model from one provider. It actually orchestrates a specialized hierarchy of models, and it bases that on capability and, crucially, cost.
Here's where it gets really interesting, because the cost disparity between these modern AI models is massive.
It's huge.
Let's break down this 4-tier stack. Start from the very top, the God tier.
Okay, Tier 1 is Claude Sonnet 4.6. This is the heavyweight champion.
The big guns.
Yeah, it is brought in solely for impossible coding tasks. We are talking deep architectural refactoring, complex logic bugs, or situations where you just require flawless reasoning and massive context windows.
But relying on that level of compute for every single keystroke would literally bankrupt an independent developer.
Oh, instantly.
I was looking at the API costs, and running Claude Sonnet 4.6 actively for an hour comes out to about $15 US.
Which is wild to think about.
You are basically burning a standard Netflix subscription every 60 minutes.
Right. And that financial reality is exactly why Tier 1 is strictly treated as a highly paid consultant. It's a nuclear option you only invoke when you are fundamentally stuck.
You don't call the consultant to fix a typo.
Exactly. You don't ask the $15 an hour consultant to format your JSON or write a standard loop. For that, you drop down to Tier 2.
Okay, what's Tier 2?
The analyst. This is DeepSeek V4 Pro.
And it cost on that?
It costs about $1.50 an hour.
Oh, wow. Huge drop.
Yeah. And it is highly educated and worldly, so it's perfect for thoughtful planning and breaking down a feature into actionable steps.
So it's a tenth of the price for the architectural planning.
Yeah.
But even then, when it's time to actually generate the hundreds of lines of boilerplate code, $1.50 an hour still adds up if you're working all day.
Which brings us to Tier 3, the tireless worker.
Love the name.
This is DeepSeek V4 Flash. This model costs a fraction of a penny per API call.
A fraction of a penny. That's practically free.
Basically. It doesn't need to philosophize about software architecture. It just takes that highly structured plan that the analyst generated in Tier 2, and it grinds out the actual implementation.
And then there's a final tier, right? One that completely removes the cloud from the equation. Tier 4. The reliable intern.
Yes. Tier 4 runs the Qwen 3.635B model.
Okay.
And the crucial distinction with Tier 4 is that it runs entirely locally on your own machine.
Using a llama, right?
Exactly. Using a llama, it never touches an external network. And because it's running locally, it costs exactly $0.
Incredible.
You deploy the intern for small, annoying jobs, syntax reminders, explaining a weird compiler error, or just having a localized rubber duck debugging session where privacy is paramount.
But wait, if I have 4 distinct models, managing the context handoff between them sounds like an absolute logistical nightmare.
It usually is.
Right, because in most environments, you'd have to manually copy the analyst output, open a new chat window with the worker model, paste it all in, and just kind of hope it understands the context.
Yeah.
I'm assuming ZorgStudio automates this routing.
It does. It ties the specific model directly to the agent's state through a single keystroke.
Really, just one key.
Yeah. When your cursor is in that left pane, you just press the Tab key to toggle between plan mode and build mode.
Oh, that's smooth.
Right. In plan mode, your prompt is routed to the DeepSeek analyst. Hit Tab again, you're in build mode, and it automatically routes the next instruction to the DeepSeek Flash worker. And the context is preserved seamlessly between the calls.
So you essentially have a massive corporate software team just sitting at your disposal.
Pretty much.
You have the senior architect outlining the sprint, the junior developers churning out the actual code for pennies, the local intern answering syntax questions for free, and then that $15 an hour consultant just on retainer for emergencies.
It is a masterclass in automated resource allocation. It provides the capabilities of an enterprise environment while fiercely protecting your budget.
Okay, so we just touched on how the context is preserved across these different models. But if you were working for, say, 3 or 4 hours, generating thousands of lines of code and analysis, the terminal buffer is eventually going to fill up.
Of course.
And you lose history when you close at the standard terminal.
Uh-huh.
I'm assuming there is a persistent state somewhere so you don't lose that genius architectural plan the analyst generated yesterday.
Yes, absolutely. Everything is written to a flawless, structured memory system. Every single interaction in that left pane is recorded into a single SQLite database.
Okay, where does that live?
It's located in your local share directory, just called opencode.db.
Got it.
And it captures everything: the chat messages, the to-do items generated by the models, the exact outputs of any bash tools the AI ran, the token counts, the cost of that specific prompt, and even which model was used.
That is comprehensive.
Very. To give you a sense of scale, Terry Porter's personal database sits at about 172 megabytes, and it holds 159 massive development sessions.
Wow, 172 megabyte SQLite database of pure text.
Yeah.
That is massive.
It's huge.
But wait, if it's one global database for every single project on your hard drive, finding the context for the specific Python script you were working on today, it could be like finding a needle in a haystack.
It would be, but the system uses directory scoping to solve that.
Directory scoping, how does that work?
So inside that SQLite database, there's a project directory table, and it basically acts as an index. It maps specific file paths on your machine to their corresponding project contexts.
Oh, I see.
Yeah, so when you launch ZorgStudio, it automatically checks your current working directory. It queries the database and instantly loads only the history relevant to that specific folder you're sitting in.
That is brilliant. It's intelligently querying its own memory based on where you are physically sitting in your file system.
Oh, exactly. And if you need to jump back to a specific train of thought from, say, last week, you can just use the sessions command. It pulls up a list and you resume perfectly.
So the AI remembers exactly where you left off.
Down to the specific tool outputs.
Okay, so we have the memory, we have the multi-model engine, and we have the 3-pane layout. But there is a 4th pane we haven't discussed yet, and it fundamentally changes how you interact with this whole environment.
Yes, the voice component.
The sources mention a companion tool called ZorgSpeech.
Right. So if the startup script detects ZorgSpeech on your system path, that TEE-MUX layout dynamically expands.
It just shape shifts.
Exactly. The bottom right corner shifts, and it carves out a tiny 4th pane. It's just 3 lines tall.
Okay.
And it features this little ASCII art face. That is the voice-to-AI user interface.
I want to dig into the technical pipeline here, because voice control in a terminal usually involves massive latency or, brittle cloud APIs. The fact that this is all orchestrated by a bash script is fascinating. Walk me through the actual mechanism of speaking to the AI.
The whole goal here is frictionless interaction, right? Imagine your hands are on the keyboard, you encounter a complex architectural problem, and typing out a whole paragraph of instructions is just way too slow.
It breaks your flow.
Exactly. So you simply press the I key on your keyboard.
Just I.
Just I. The script immediately hooks into Pulse Audio and actually mutes your computer's speakers.
Oh, to prevent any audio feedback loops from whatever you're listening to.
Precisely. A recording timer appears in red text on that little pane, and you just start talking naturally.
And then when you finish your thought, you press I again, the speakers unmute, and the recording stops.
Okay.
But what is doing the actual transcription?
In the background, the script triggers a bundled executable and by 8664 binary of whisper.cpp.
Okay. Whisper.
Yeah, and it leverages the GGML small model, which is roughly 490 megabytes.
Using the C++ implementation of Whisper is a brilliant architectural choice.
It really is.
Because it means it's doing CPU inference, right? You don't need a massive, expensive GPU to run the transcription locally.
Exactly. It just uses your standard processor, which guarantees absolute privacy since the audio literally never leaves your machine.
So it processes the audio locally, then what?
It generates a JSON file containing the transcribed text. But, raw JSON is cluttered with timestamps and confidence scores and all that junk.
Right.
So a tiny Python script called wave2miller_dead instantly parses that data and converts it into perfectly formatted markdown.
And then it injects that markdown directly into the paste buffer.
Yeah.
Right, pasting it seamlessly into the OpenCode input line in pane 0.
That's the one.
The sheer speed of this pipeline is what really stands out in the sources. From the moment you press I to stop recording, to the moment perfectly punctuated markdown appears in the AI's chat box. Takes about 8.3 seconds.
And the UI keeps you informed the entire time, too. It shows recording in red, then transcribing in yellow, and finally pasted to OpenCode in green.
Nice and visual.
Very. And then it aggressively cleans up after itself, automatically deleting the temporary audio files so your drive doesn't fill up.
This just highlights the beauty of the Unix philosophy. A 59-line bash script doesn't need to contain complex audio processing algorithms itself.
No, not at all.
It just glues together small, sharp tools. It orchestrates audio daemons, local C++ neural networks, Python parsers, and terminal buffers. And it abstracts all that complexity away so the human just presses the letter I.
It reinforces that central thesis perfectly. The technology running under the hood is incredibly complex, but the interface serves the human's natural workflow.
Okay, so we just talked about how ZorgStudio relies on a single SQLite database for its memory and context.
Right.
But what is truly radical to me is that Terry uses that exact same database philosophy for the software's distribution itself. Because ZorgStudio is not hosted on GitHub, right? And you can't just install it via a standard package manager.
No, you can't. It is distributed as a single file, zorgstudio.fossil.
Fossil.
Yeah, it utilizes the Fossil distributed version control system, which, fun fact, was actually created by the exact same person who invented SQLite.
Oh, that makes perfect sense then. But in a traditional Git workflow, your code lives on your machine, but your issue tracker, your wiki, and your pull requests, they all live on a centralized platform like Microsoft's GitHub server.
Exactly.
Fossil takes a completely different approach.
Night and day difference. Fossil puts the entire universe of the project, the source code, the bug tracker, the wiki, the design documents, and the cryptographic history of every version ever committed into one self-contained SQLite database file.
Just one file.
One file. Terry manages between 200 and 300 of these single-file repositories for his various projects.
But wait. If the project doesn't exist on a centralized web platform, how does the open source community actually contribute? You can't just click a button to open a pull request.
It operates on a patch-by-email culture.
Okay, walk me through that.
So, to contribute, you clone that Fossil file to your local machine, you make your code changes, and you commit them. Then the system generates what's called a Fossil bundle.
Which is what exactly?
It's a tiny, highly compressed cryptographic delta containing only your specific changes. You just attach that tiny file to a standard email and send it directly to Terry.
And that's it?
That's it.
Okay.
When he receives it, he runs a single command, Fossil bundle apply, and your contribution is instantly merged into the project's history.
The workflow fundamentally shifts the power dynamic of open source software.
It really does.
Because the modern pull request ecosystem, it demands a high bandwidth, always-on internet connection. It requires you to create accounts on third-party platforms, manage SSH keys, and agree to, corporate terms of service.
And the patch-by-email model radically reduces all of those barriers. It respects human agency by basically stating you don't need a fast connection or a corporate identity to participate. You only need the ability to download a single file, write effective code, and send an email.
It is inherently decentralized and resilient.
Extremely resilient.
So for someone listening who actually wants to test this resilient, decentralized workflow, the setup process is surprisingly straightforward, despite stepping outside the familiar GitHub ecosystem.
Yeah, setting up your first session takes maybe 10 minutes. You download the zorgstudio.fossil file, clone it, and extract the workspace.
Okay, easy enough.
Then you run the included.setup.sh script, which handles all the necessary symlinks and folder structures automatically.
Then you just need to provision your models, right?
Right. You configure your API keys for OpenRouter so you can access the Claude God tier model. You set up your DeepSeek endpoints for the analyst and worker tiers. And then you pull the Quinn model down locally using a llama.
And what about the voice stuff?
If you want the voice capabilities, you just download the 490 megabyte Whisper model from Hugging Face.
But what if I don't want the voice stuff?
That's the best part. The architecture is designed with graceful degradation.
Meaning?
Meaning, if you decide you just don't want to dedicate the hard drive space to the speech model, you simply skip installing ZorgSpeech. The startup script detects its absence and smoothly falls back to the pristine 3-pane layout instead of 4.
So nothing breaks?
Nothing breaks.
Yeah.
The system just adapts to what you have provided.
I love that. Before we wrap up, though, there's one detail hidden in the Fossil repository logs that I think perfectly encapsulates this entire project.
Oh, I know what you're going to say.
If you look at the commit history showing how ZorgStudio was actually built, every single commit explicitly documents which AI model wrote the code.
Yes, the commit messages literally end with tags like model.deepseek v4 flash or model.deepseek v4 pro.
It is such a brilliant self-referential loop. You are looking at a tool designed to orchestrate artificial intelligence, which was itself architected and built by artificial intelligence.
Exactly.
But because of that meticulous documentation, you have a completely transparent public record showing exactly how the $1.50 an hour model solved a specific problem versus, say, the free local model. It demystifies the whole AI development process entirely.
It proves that these models are just tools in a broader system. They wrote the code, sure, but Terry Porter directed the symphony.
So what does this all mean? We started by talking about a 59-line bash script, but we've unpacked an entire paradigm shift today.
We really have.
ZorgStudio is a completely voice-enabled 4-tier AI environment disguised as a retro-terminal layout. It leverages the Unix philosophy to orchestrate Python parsers, C++ neural networks, and global API endpoints, all packaged within a single offline fossil file.
That's quite a feat.
But more importantly, it is driven by the philosophy that technology, no matter how advanced it gets, must serve human agency. The human has to be the one pressing the I key.
And it leaves us with a really compelling question about the future of our digital infrastructure.
Let's hear.
Well, if an incredibly complex, multi-model AI coding studio, complete with CPU-based voice recognition and flawless SQLite memory, if all of that can be fully documented, version-controlled, and entirely self-contained within a single offline file that fits on a cheap thumb drive,
Right.
are we approaching a new era of software? An era where our most powerful tools aren't hosted in the cloud as a rented service, but are instead passed around like digital heirloom seeds.
Oh, wow. Heirloom seeds. I like that.
Tools that belong entirely to the user, completely immune to the pricing changes, internet outages, and just the general whims of massive tech platforms.
It forces you to consider how much power we've willingly handed over to centralized platforms and how easily a 59-line script proves we could just take it back. Because just like Zorg choking on the cherry, all the high-tech infrastructure in the world is completely useless if it can't save you when the connection drops.
Exactly.
You have to put yourself in the center of the loop. So, to echo the sign-off from our sources today, take these tools, maintain your agency, and go build something impossible.
This concludes the podcast. Thank you for watching. I hope you have found this podcast useful, and as always, if you have any constructive comments, I would like to read them, so drop them in the comments section below.